Hi everyone, thanks for tuning in. In a previous video I showed my first prototype for the DC-64, a small add-on board for the Commodore 64 that allows replacing the original transformer with a modern 12V DC power supply. Perhaps go watch that video first, as it will make this one easier to follow, since we'll remove the prototype version from my computer and replace it with the new beta version, while also covering some important aspects of the installation process. This new beta version improves upon the prototype by using a crystal oscillator as a clock source, as opposed to an RC oscillator, thus being able to generate a very precise time of day clock without any manual calibration. After using the first DC-64 prototype daily for the past few weeks, I noticed that C88 doesn't really contribute in filtering the output ripple of the 15V supply, and instead generates a significant inrush current at startup. This is not a big issue since the DC-64 has a current limiter, but I decided to remove it anyway. Now it's time to remove the old prototype and install the new beta board. Clear wiring instructions are now printed on the bottom of the board, and the time of day clock can be selected between 50 and 60 Hz by simply closing a solder jumper. Like with the previous prototype, the beta version is installed in place of C19 on the motherboard, and generates additional 15V DC and 5V DC that need to be connected appropriately. Once again, an external 12V DC supply needs to be provided on pins 6 and 7 of the original power supply, which were originally assigned to the input AC voltage. Because of this, once the DC-64 is installed, all current powering the system goes through the AC rectifier bridge present on the C64 motherboard, which dissipates a significant amount of power and tends to get rather hot, often above 90 degrees Celsius. In order to mitigate this issue, we can bypass the negative leg of the rectifier, which will effectively halve its power dissipation. This is done by shorting the pin of the rectifier that is connected with the negative terminal of the external power supply, in my case pin 7 of the original power connector, with the rectifier pin connected to the system ground, which is usually marked with a minus on the top side of the motherboard. Thanks to this simple modification, the rectifier temperature is now very manageable and poses no evident threat to the computer's long-term operation. Another important point is the replacement of the original fuse. Once again, the fuse is carrying all the current powering the system, and thus should be upgraded from 1A to 2A. 2A is a safe limit that will help protect the DC-64 and the computer as a whole in case something goes wrong, so I wouldn't go above that. With this new board, the time of day clock is connected directly to the positive terminal of the Zener diode CR1 and only requires disconnecting either leg of R5. This new method is a lot easier to both implement and revert than my previous solution. Now that the board is installed, we can see that unlike with the previous iteration, the time of day clock is extremely precise. And while I put everything back together, I'll also install the new beta version of my Blue-64 project, which allows controlling the C64 with Bluetooth controllers and keyboards. In terms of temperature, with a room temperature of 20 degrees Celsius and after about 30 minutes playing a game from an Ultimate 2 cartridge, I opened the chassis and measured very reasonable temperatures between 50 and 60 degrees Celsius, so nothing to worry about. In addition to real-world use, I also carried out several performance and safety tests, some of which destructive, to make sure that the DC-64 can keep working in pretty extreme conditions, and that when it fails, it does so gracefully and safely for the rest of the system. This was a short video, but I just wanted to give an update on the state of my projects and show that a few beta boards for both DC-64 and Blue-64 are available, so please feel free to get in touch via Discord if you'd like to participate to the beta. All design files, documentation and performance metrics can be found on GitHub at the link in the video description. Anyway, I hope you found this video interesting, thanks again for watching and see you all next time.